My name is Andrew Coble, and this is my Project 7 presentation for CE 570. The objectives for this project were to define a deformation map for my 3D body, calculate tangent vectors on the undeformed body, calculate the deformation gradient of the map, and then finally, this is the new part, is to verify a deformed area and a deformed volume on the composite body. So here is my vector field, as well as my deformation map, and then my vector field that is defined in MATLAB. This is just a quick overview from the last project. We have my hemisphere, cylinder, and upright cone, and I'm finding the tangent vectors of each of those bodies, and then on the right-hand side is those tangent vectors from my MATLAB code. Now here is my deformation map, as well as the deformation map applied to each of the bodies, the hemisphere, cylinder, and cone, respectively. This slide, I'm just kind of going through and displaying each of my surfaces. Here are my MATLAB code for the two hemisphere surfaces, the exterior surface, and then also the bottom of the hemisphere. And then this is just the outer surface of the cylinder and the outer surface of the cone. I decided to choose the outer surface of the cone to do my deformed area calcs on. All right, so here is the verification of the calculation for my deformed body. At the top, we started by parameterizing the undeformed area, which is just from my MATLAB code. There is my calculation for my undeformed area of the cone. And then here is the deformation map that we applied. And then the area Jacobian calculation with respect to theta and z. And then we also found the magnitude. And then I plugged that magnitude into the double integral, which is basically finding the deformed area. This is, again, with respect to theta, which is running from 0 to 2 pi, and then from 0 to 18 with respect to z. Used the Wolfram alpha integration tool, and it came out with a value of 309.84. And if you take a look at my undeformed area and my deformed area that I came up with, these check out with what my MATLAB code came up with. Here I basically did the same thing, but this is applying to the volume of the cylinder. I parameterized the cylinder. I found the undeformed volume, which is 402.1239. I displayed the deformation map up here. Then I applied the volume Jacobian, which is just a scalar triple product. I found the value of that right here. I plugged that into the triple integral. I integrated from r, or with respect to r, which is running from 0 to 8, with respect to theta from 0 to 2 pi, and then finally z from 18 to 20. And that gives me a value from the Wolfram alpha integration tool of 326.38, and that lines up with our value displayed from MATLAB for the undeformed and the deformed volume. All right, so you can see here is my deformation gradient and my map for the hemisphere, deformation gradient and map for the cylinder, the deformation gradient and the map for my upright cone, and here is my vector field for my body. I'll run the code real quick. We have the undeformed body and the tensor field on the left-hand side, and then we have the deformed body on the right-hand side. All right, and finally, we'll take a look at the command window output. As you can see here are all the undeformed and the deformed areas, undeformed lengths, deformed lengths, undeformed and deformed areas, and undeformed and deformed volumes. Thank you guys for watching.